Imagine 10,000 mirrors the size of king-sized beds, all aiming sunlight at a single tower in the middle of the desert. Now imagine those mirrors heating it to 1,000 degrees Fahrenheit, creating power so intense the plant keeps generating electricity even at night. No solar panels required. China built this in the Gobi Desert, and it's already online. And the next step, dual tower systems, could completely change the future of renewable energy. Here's why the world is paying attention. Picture a 200-meter tower rising from the empty expanse of the Gobi Desert about the height of a 60-story building. Surrounding it, across 2 to 3 square kilometers, sit more than 10,000 heliostats, each roughly the size of a king-sized bed. Every mirror moves independently. Guided by AI, they track the sun in real time, adjusting their angles every second to reflect sunlight onto a receiver at the top of the tower. When thousands of beams converge on that single point, temperatures climb above 1,000 degrees Fahrenheit, hot enough to boil water instantly. This system powers the Qinghai Gonghe solar thermal power plant, delivering around 50 megawatts of continuous electricity, enough for roughly 100,000 homes. And it operates in one of the toughest environments on Earth. Winter temperatures drop to minus 30 degrees Celsius, and summer sandstorms routinely blanket the desert. The larger significance comes from where China is heading next. Engineers are already testing dual tower prototypes in other regions, with plans for facilities using 20,000 to 27,000 heliostats by 2026 and 2027. Gonghe marks the beginning of a much broader expansion. So how does this plant keep generating electricity long after sunset? Solar thermal power works differently from the photovoltaic panels on rooftops. Instead of converting sunlight directly into electricity, this system concentrates the sun's heat. Over 10,000 mirrors focus sunlight onto receivers at the top of the tower, heating molten salt, a blend of sodium and potassium nitrate, to around 540 degrees Celsius, roughly 1,000 degrees Fahrenheit. Think of it like heating liquid in a pot, but the pot is filled with molten salt and the burner is the concentrated power of the sun. Once heated, the molten salt is pumped down into heavily insulated storage tanks that hold the heat for hours, sometimes even days. When electricity is needed, the hot salt passes through a heat exchanger, boiling water into steam. That steam spins turbines, producing power in the same way a conventional plant does, but without burning fuel or emitting carbon. The real advantage appears at night. Even after the sun sets, the stored thermal energy keeps the plant running. The molten salt remains hot enough to produce steam for up to 15 hours, allowing continuous generation through the evening and early morning. This solves one of renewable energy's biggest challenges, providing steady, reliable electricity when sunlight and wind aren't available. The location of this plant tells you exactly how strategic China's approach is. Choosing the Gobi Desert wasn't random, it was engineered. First, the region receives some of the strongest and most consistent sunlight on the planet, around 3,000 hours per year, roughly double cities like London. For concentrated solar power, consistent high-intensity sunlight is the key ingredient. Second, land in the Gobi is extremely cheap. Large solar thermal facilities require huge footprints, and unlike China's crowded coastal regions, the desert offers vast, low-cost space with no displacement issues. Third, northwestern China needs power. The region is expanding rapidly with new factories and cities, yet it sits far from the coal-heavy energy centers in the east. Building renewable power locally reduces transmission costs and helps China move toward its climate goals. China's targets, peak carbon emissions by 2030 and carbon neutrality by 2060, are backed by massive national investment. This plant is one part of a broader strategy that includes wind, hydro, nuclear, and hydrogen, all aimed at reducing coal dependence. China already dominates global solar panel manufacturing, producing nearly 80% of the world's supply. Now they're aiming to take the lead in concentrated solar thermal as well. By building and operating facilities like Gonghe, China is positioning itself to export this technology to regions such as Africa, the Middle East, and South America. And the dual tower prototypes now under testing, they could significantly increase capacity while improving efficiency. China is methodically addressing the technical challenges and preparing to scale this technology worldwide. Traditional solar panels come with a hidden weakness. They rely on silicon, rare earth elements, and globally distributed supply chains. If those supply chains are disrupted, the entire renewable energy rollout slows down. Solar thermal plants like Gyeonggi avoid this problem. They run on materials almost every country can source domestically: mirrors, steel, salt, and concrete, giving nations a level of energy independence solar panels can't provide. The US actually pioneered concentrated solar thermal decades ago. California's Mojave Desert has plants from the 1980s, and Spain built several in the 2000s. But when solar panel prices collapsed, largely due to China's dominance in manufacturing, most Western countries stopped investing in solar thermal. It was seen as too expensive compared to photovoltaics. China took a different path. They focused on the two biggest weaknesses in renewable energy: storage and baseload power. Solar thermal energy could solve both, so instead of abandoning it, China poured billions into R&D and large-scale demonstrations like Gyeonggi, with even larger projects already under construction. The dual tower designs now being tested are especially important. A single tower loses efficiency when mirrors are placed too far away. Two towers allow the field to expand without sacrificing performance, effectively doubling capacity while keeping mirror efficiency high. Prototypes are already operating in Dalinga and the Tenga Desert. But the biggest breakthrough may be in the control systems. Managing more than 10,000 heliostats, each adjusting in real time to track the sun while accounting for weather, dust, and mechanical wear, requires advanced software and AI. China has been developing these systems for years, and Gyeonggi proves they work at commercial scale. Next-generation plants are expected to control 20,000 to 27,000 mirrors, pushing the engineering limits even further. Before calling this a perfect solution, we need to look at the challenges, because they're significant. First, maintenance. A field of more than 10,000 mirrors sitting in a desert means constant exposure to dust and sandstorms. Reflectivity can drop by 20% in just a few days if mirrors aren't cleaned. Whether done by automated systems or workers, keeping thousands, soon tens of thousands of heliostats clean is a massive ongoing effort. Second, water use. Solar thermal plants need water for cooling steam turbines and cleaning mirrors. In deserts, water is scarce and expensive. While China uses air cooling where possible and still consumes far less water than coal plants, it's more water intensive than solar panels, which need almost none. As drought risks rise, this becomes a real concern. Third, cost. Gyeonggi's 50-megawatt plant costs hundreds of millions of dollars. The next-generation dual-tower facilities, 100 to 200 megawatts, will cost in the billions. That's roughly triple the price of an equivalent solar panel farm. The trade-off is storage and nighttime power, but the upfront investment is enormous and out of reach for many countries. Fourth, efficiency. Even under ideal conditions, concentrated solar thermal converts only 30 to 40% of sunlight into electricity. Modern solar panels can match or exceed that, and they keep improving. Thermal storage is the main advantage here, but it must justify the higher cost and complexity. And finally, wildlife. Large heliostat fields can create intense solar flux, a beam of concentrated heat that poses a danger to birds. The temperature can get high enough to incinerate birds mid-flight, creating what environmentalists call streamers. It's a known issue across solar thermal plants worldwide. This plant represents more than a single project in the Gobi Desert. It shows how strongly China is committing to energy diversity. Instead of relying mainly on wind and solar panels, China is advancing multiple technologies at the same time: wind, photovoltaics, nuclear, hydro, hydrogen, and now large-scale solar thermal. A diversified approach improves energy security by spreading risk. If one technology encounters setbacks, others can compensate. China's concentrated solar power capacity is now about 1 gigawatt across several sites, with plans for further expansion. Each installation provides new data on scaling, cost reduction, and efficiency improvements. Regions with abundant sunlight and wide open land, such as the Middle East, North Africa, and Australia, are watching closely. Saudi Arabia has announced interest in building similar solar thermal plants. Australia is evaluating options for the outback. Morocco already operates a functioning facility and is planning to grow it. The geopolitical implications are significant. Countries that master renewable energy systems can become major energy suppliers in the 21st century, much like oil-exporting nations shaped the 20th. China is positioning itself for that role by developing multiple forms of renewable technology, including advanced thermal storage. Energy storage remains a core challenge for renewables. Batteries are useful but expensive at grid scale. Molten salt thermal storage offers a potential solution by providing stable, dispatchable power suitable for baseload needs, the electricity required to keep hospitals, factories, and data centers operating around the clock. If China can demonstrate that this technology works reliably and economically at scale, and if costs fall through mass deployment as they did with solar panels, concentrated solar thermal could spread far faster than expected. The larger dual-tower facilities planned for 2026 and 2027 will be essential in determining whether this technology can scale effectively. Step back, and the bigger picture becomes clear. China is running the largest energy transition experiment in human history. They are still building coal plants, but at the same time, they're constructing renewable facilities at a pace no other nation can match. The strategy is simple: keep the grid stable while transforming it without slowing down the industrial engine that powers their economy. The Gonghe solar thermal plant is just one piece of this strategy. China is also building floating solar farms on reservoirs, massive offshore wind projects, next-generation nuclear reactors, including thorium models, and even experimental fusion facilities. Trillions of dollars are being poured into every technology that might shape the future. What makes this approach powerful is the learning curve. Gonghe uses more than 10,000 heliostats. The next plants will use 20,000 to 27,000. Each new facility teaches China how to manufacture cheaper mirrors, design smarter AI control systems, improve maintenance, and scale the technology. By the time other countries begin investing seriously in concentrated solar thermal, China will already have years of operational data and a manufacturing ecosystem that no one else can replicate. Yes, Western nations criticize China for continuing to build coal plants, and that criticism is fair. But at the same time, China installs more renewable energy capacity each year than the rest of the world combined. They're hedging their bets, using fossil fuels to maintain reliability while racing to build the renewable infrastructure that will eventually replace them. It's a pragmatic strategy. China watched Europe's energy crisis unfold, where dependence on Russian gas created massive vulnerabilities, and decided they would not repeat that mistake. Their solution is diversification. Develop every viable energy source, build domestic supply chains, and ensure they never rely on another country to keep their lights on. So here's what keeps energy experts up at night. Gonghe proves the technology works with 10,000 mirrors powering 100,000 homes. If China's dual-tower prototypes succeed, if they can scale to 20,000 or 27,000 heliostats and drive costs down the way they did with solar panels, then they'll have cracked the code on renewable baseload power. That's the holy grail of clean energy, the thing everyone has been searching for. There's another development unfolding that almost no one is watching. While attention has been on the Qinghai facility, China has already begun building even larger pilot plants in the Gobi Desert and other remote regions, projects that make Gonghe look like an early prototype. When those sites start operating in 2026 and 2027, the global energy landscape could shift in ways the world has barely started to recognize. The real question goes beyond whether renewable energy will overtake fossil fuels. The real question is, who will control that future? Let us know your thoughts in the comments section. If this solar breakthrough surprised you, wait until you see the reactor China built to run day and night without ever shutting down. A world-first design that could rewrite the future of clean energy. Click watch next to see that video. Thanks for watching.